So I'm going to elaborate on the disadvantages of nuclear power. I'm going to focus on waste and also efficiency and disasters. We're going to start. Before I cover it, I just want you to know that here's what's involved in nuclear power plant life. And that's something I mentioned at the end of our discussion on the previous video. When a nuclear power plant is built, it goes through these phases that take some time, but a lifespan of a nuclear power plant cannot surpass 40 to 60 years. Because of the excessive radiation during fission, there's deterioration within the reactor core, containment shell, and it has to be rebuilt, but eventually it's just so bad that it's basically going to be shut down. So the plant completely shuts down. The dealing with waste is a huge component that exceeds this time frame, the 40 or 60 years, and I'm going to talk to you about that next. So when a plant, when nuclear power is mined, when it's produced, and when it undergoes fission, radioactive waste is produced. They categorize it into 3 levels. Low level, which is little radiation, is basically produced during mining. So any kind of tailings are going to have low levels of radioactive waste. And then anything in the plant that is exposed to any kind of radiation that's not considered high levels, like your clothing, rags, even parts, they're considered low level waste. Then you move into intermediate, which is actually highly radioactive. This is a picture of like the reactor core. So anytime there's going to be decommissioning of structures, they're going to be considered intermediate level or high level radioactive waste. So they are highly toxic, but or not toxic, but highly radioactive. But the only one that's considered high level, and there should be an L here, there it is any part of the fission reaction. They consider this, or they call it spent fuel. So once uranium undergoes fission, which it does so for a pretty long period of time, that waste has to be dealt with. And it takes a lot of effort. And I'm going to talk about all the waste first, and then specifically how this one's treated. So low-level radioactive waste is placed in steel in these types of drums. They're not steel. They're made up of strong materials, and they're buried. And this is just a picture of world dumping in oceans of low-level radioactive waste. So you could see that there is also not just on the surface or on land, but in oceans they throw this waste. High level, first of all, a fuel pellet can undergo fission in a reactor for 3 to 6 years. Once it stops, it's still highly radioactive, so they have to put these pellets into these pools, which is known to be really excessively packed. So they're putting excessive amounts of pellets in a fuel pool, which the power plant has to supply or provide, and it could be there for up to 20 years, depending on radiation. If you look at notes that I provided in previous years, they might have been there for 6 years. So basically they're realizing that it takes almost 20 years for the radiation to get to a point where then it can be placed in these containers, which are steel drums, and this is what they look like here, very high, and then they're dumped in a variety of sites. And something that's getting really popular right now is the Yucca Mountain. They are considering putting a lot of high-level radioactive waste. They're going to kind of stuff it into the mountain. So nuclear disasters is a big deal. One of the biggest reported nuclear disasters of all times was Chernobyl. It happened in 1986 in Russia, and in Chernobyl, but it's near Russia, or a part of Russia. I have some links here to some videos which I was going to show in class. But I want you to know that basically this explosion took place due to really poor decision making and reactor design malfunctioning. Reactor literally exploded due to excessive heat not being able to be controlled because they decided to not put in the control rods and eliminate so they could produce excessive amounts of power. Once the explosion took place, they actually did not let residents know for a short period of time, well, more than one day, to see if they could get it under control. And eventually they had to evacuate the whole area because of radiation. Most people that tried to put out the fire or were in the scene died immediately due to radiation poisoning. And basically that means your organs burn because the radiation goes right through you and burns your organs. Chernobyl today looks like this. This is a dome that was built, and this diagram shows you that that dome, which is made of steel and concrete, is there because the radiation that's being emitted cannot be controlled, and they have to contain it. So that's basically what they're doing. This is the second dome that's built because the first dome, due to excessive amounts of radiation, is basically deteriorated, and a new dome had to be rebuilt, or else the radiation was going to be emitted. Another nuclear meltdown, or partial, occurred at 3 Mile Island in Pennsylvania. This is a United States nuclear meltdown. And again, it was partial. It was also due to mechanical and human errors, and it led to a partial meltdown of one of the reactors. Radiation emitted into the atmosphere, but any kind of documentation that you read pretty much shows that there was no casualties due to this radiation. There's some documentation of there possibly being symptoms of victims years later due to being exposed, but there's no truth to any of that. Then you know that the disaster, which you guys are pretty much aware of, that took place in Japan. This was not a disaster of human error or malfunctioning of a power plant. It was initiated by a tsunami or an earthquake that occurred in Japan. And what happened was, because of the loss of power, the reactor core was not receiving water to cool down the system. So eventually it overheated, and there was an explosion of not just 1, 2 reactors, but 3. And I have links here to the videos, which I'll show you later in class. Now, lastly, I want to talk about efficiency. Remember that when we started learning about nuclear power, one of the reasons why we switched from fossil fuels to nuclear power for electricity production was because one pellet can do the same as a ton of coal to generate electricity. And it was considered one of the most efficient forms of electricity production. But because of this, the need for energy to deal with the waste, the need for energy to decommission these power plants, and the amount of energy it takes to do these things puts nuclear energy as the least efficient form of energy for electricity production. You can't just consider what the input is when considering efficiency. You have to consider the whole process, the throughput. So although when you put a pellet in a nuclear reactor, it can produce tons of heat, much more than coal, the process that you have to deal with to remove waste, get rid of deteriorating power plants, all that energy has to take into consideration as the yield of energy decreases because of this. So nuclear energy is now considered one of the least efficient forms of fuel.